Okay, what I'm going to do here is I'm going to show you how to add vector electric fields. Okay, now for an electric field, the key formula here is that the electric field is K Q over R squared. Don't forget that it's R squared. Okay, where K is our constant 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. Okay. So the first step, the first thing you want to do is take a look at the problem here, right? This charge here is negative 14.7 times 10 to the minus 6 coulombs. That's A, right? So I'm going to put a big minus sign on there just so I don't forget that that's negative. And B is positive 17.2, so I'm going to put a positive there. Now, remember that it's away from positive and toward negative, right? And so we're being asked to find the electric field here at the origin, okay? And so what we got to do is we've got to figure out what direction those electric fields are. So the electric field due to A is going to be actually toward A, and that's because for negative charges it's toward the negative ones. Positive charge would move toward the negative one, right? And because of B, it's going to be actually away from B, right? And so this guy is going to be like this. Okay? So this is the electric field of B. Here's the electric field of A. Okay? So that's the first thing, I think, is to find the directions. Okay? Okay? The next thing to do, the second thing to do, I think, is to find the magnitudes. Okay? Right? So I think that's what I'm going to do next, right? So the electric field of A, let's figure that out, right? That's going to be, I'm just using KQ over R squared, right? So 8.99 E9. And then A is 14.7 times 10 to the minus 6th, right? And now the distance squared is, we can do the same thing we did with Coulomb's law, right? I can just do, this thing is up 1 and over 1, 2, 3, 4, right? So it's really, remember, it's the square root of 1 squared plus 4 squared. Why did I make that so long? Look at that. Okay? And then that whole thing is squared, right? So really what happens is the square root goes away. It's the square root squared. Okay? So when I put it into my calculator, I can just do this. I can go 8.99 E9, right, times 14.7 E minus 6 divided by parentheses 1 squared plus 4 squared. Ta-da. Okay, and I'm going to store that into A just for fun. Okay, and that's quite large. That's 7773.7 newtons per coulomb. Okay? Did I do that right? It looks like I did. Okay. And now let's find the magnitude of B. Right, and that's going to be 8.99 E9. And then B is 17.2 microcoulombs. 10 to the minus 6th coulombs, right? And then if you look at B, B is down 2 and over 2, right? So it's going to be, I'm just going to go 2 squared plus 2 squared. Now remember, that's the square root of 2 squared plus 2 squared squared, right? That's what it is. That's why I can just do that. Okay? And so that looks like this. Let's see, 17.2. Okay, and then that's going to be 2 squared and 2 squared. And I'm going to store that in B. Hey, my daughter's got the music going on here for us. Okay. And so that is 19,328.9 0.5. Now, not all those digits are significant, but you know, there we have it, right? Okay. Now we've got the magnitudes. Now we got to figure out the directions, and we've got to figure out a trig angle, right? So for B, this is easy, right? If you look at that, it's going to be the opposite angle. That's got to be 2 and 2. That's got to be 45 degrees. Okay, and then A is going to be this angle here. Okay, now to figure out that angle there, I think that angle is going to be 180 minus whatever this angle is here, right? I just figured that one out, right? Okay, and that little angle there is the inverse tan of opposite over adjacent, so 1/4. Right? I can find this little angle right here is the opposite side is 1, the adjacent side is 4. Okay, so let's figure that out here. 180 minus the second tan of 1 divided by 4. Okay, 165.96. Okay, now I'm just going to do a quick check here, a quick peek. Am I in degrees? Yes, I am. Okay, that's good. Isn't that good to know? Okay, so now I'm ready to go. When I do these things, I tend to put things in a table like this. Okay, so the magnitude of A is 7,770, 7773.7 newtons per coulomb, right? The trig angle for A is 165.96. For B, the magnitude was a whopping 19,328.5. Okay, that's newtons per coulomb. And that trig angle was 45 degrees. Okay, so these guys are in degrees. Okay, now the next exciting thing is to double check, right? Let's make sure that we got the right thing. Okay, here's A, and that's the 1 and the 4, and it gets that, and that's the angle. A lot of kids will get this far, and they'll mix up which thing goes with which, and I don't want to do that in a video in public here. Okay, so now we're all set. And once you have the trig angle, once you have this is just simply mag cos x if you are in degrees, and this will be mag sine x, sine of theta, sorry, not x, and this is sine of theta. Okay, y gives the sine gives you y, and x is from cosine, right? So now let's figure this out, right? Okay, so I'm just going to crank through these guys. Here I'm going to take alpha A. Is that right? And so I'm going to go, wait, second entry, second. I can't resist. Let's store that in C just for fun. Okay. So now I can just simply go, I'm not even rounding, right? Alpha A times cos alpha C. Alpha C is my, where I've got the, and this is negative 7541.6. What I did was I did 7773.7 times cos 165.96. Right, same exact thing. I should get the same answer pretty much, right? Only it's off, you know, what in the, because we rounded a little, right? Okay. So now I can do the same thing. I can go alpha A, which is this, right, times sine of alpha C, which is that angle right there, that 165.96, only it's not rounded, right? And that's 1885.4. Notice I'm not rounding these to sig figs because that would be evil, okay? And now let's just do a little double check. Let's look at that vector itself, right? It should be negative because it goes this way. It should be positive and smaller, right? So we're good so far, right? Okay. Having difficulty here sliding the paper. All right, so now let's do this guy here. This is simply going to be alpha b, which is at 19,328.5, right? And then this is going to be cos 45, whoops, times, okay, yeah, I messed up again, let's try times, there we go. Okay, times cos 45, should be a positive number, 13,667.3, right? And then of course I can do it again. I can go alpha b, which is that, right? Times the sine of, if I want to do sine of 45, it'll be the same exact thing. Whoops. Or not. Okay, alpha b, enter, times the sine of 45. Right, gives us exactly the same thing, right? 13,667.3, right? And these are all newtons per coulomb, right? Newtons per coulomb. Okay. Okay, now we're all set. X to X, Y to Y, right? Okay, so let's go 7541.6 plus 13,667.3 and get this guy here. Whoops. I forgot to make that guy negative, right? That's sort of key, isn't it? Second insert negative. There we go. So this guy is 6125.7. Okay, and now we can do this guy. Let's go second entry and make this one 185. Okay, so that's that one plus this guy here. And that's 15,552.7. Okay. And now we are all set. Let's just draw a little picture of this guy. Okay. It's going to be over a little bit and up a lot, right? Up more than twice what it is over, right? So let's go boop. Betty boop, right? And then this side is 6125.7. And then this hypotenuse will be the square root of 6125.7 squared plus 15,552.7 squared. Okay, square root of 6125.7 squared plus 15,552 squared. Is that right? Indeed it is. All right. So the magnitude is 16,715.6 roughly newtons per coulomb. Okay, and hey, that's what I got before, so that's good news. And then the trig angle here is actually this angle. That is the trig angle, anti-clockwise from the x. So that's going to be, theta will be tan minus 1 of 15,552.7 divided by 6,125.7. Are they both 0.7? That's crazy. Okay. It's crazy. Okay, so inverse tan divided by 6125.7, 68.5 degrees would be that angle there. And then the magnitude would be that, so 68 degrees. Look at that. Was it worth it? I don't know. But you can do it now. Let me turn off this recording before it gets any longer.